Okay. Is it my voice clear enough? Okay, Mr. Muhammadun, can we start right now? Okay, hello Dr. Ahmadian.
Assalamualaikum and very good morning, selamat pagi, and thank you for your invitation.
Okay, glad seeing you here again. Thank you for being here today. Since you have a busy schedule, I guess.
Sorry for rescheduling some slots because I was a bit busy, so I tried to reschedule as much as I could. So please accept my apology.
Thank you so much. Yeah, thank you so much.
Welcome.
Okay, since our speaker is already joined and ready, I think we can start our course for today. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone, and welcome to today's course series hosted by Department of Mathematics, Faculty of Science and Technology, University of Airlangga. On fuzzy logic, with today's special topic is fuzzy logic concept and definition. This topic will be delivered by Dr. Ali Ahmadian from Mediterranea University of Reggio, Calabria, Italy. For the additional information, these fuzzy courses are held in series, so there will be 4 courses for every Saturday, start at 9 until 11 p.m. So all the participants are welcome to join and follow the courses. Okay. First, let me introduce myself. My name is Asri Pratiwi, and I will be responsible for hosting today's courses. Okay, before we come to our main agenda, I would like to ask all the participants to turn on the camera because we will have a photo session. And hoping that you are already using the virtual background provided by the committee. Okay, please for the committee, you can take the screenshot right now. Is it Iksan or Dini? Then?
Okay, ma'am. Okay, take photo in 3, 2, 1. Okay, once again, 3, 2, 1. Okay.
Okay, thank you, Iksan. Okay, and for those of you just joining us, welcome. And the attendance form will be provided after the speaker presentation. Okay, before we start, I would like to inform the participant. Let me explain how you can talk to us during the lecture. If you have any questions during the presentation, just write them on the chat box, and I will read them on the question and answer session, or you can wait until the end of presentation and unmute yourself to ask directly to the speaker. The attendance will be posted during the Q&A session. Okay, Dr. Ali, are you ready?
Yes, thank you so much. So thanks again, and hope everybody has enjoying time till now. And so most important for me that after this short course, you can take effectively some advantages and motivation as well to start on working on fuzzy concept, fuzzy differential equation, and maybe fuzzy deep learning, machine learning, and so on, or fuzzy decision making algorithms. So let's at first ask that all of the participants are undergraduate student or master student, postgraduate. So may I know that mostly are undergraduate or postgraduate?
Yes, mostly are undergraduate.
I see. Okay, so we have in these 4 sessions, I try to provide the level of definitions and concept to be suitable for senior undergraduate students and also junior postgraduate. So I try to simplify some definitions. We already had a lecture before that. We review some definitions of fuzzy concept in this session. Then in the next session, we will go through the differential equations based on fuzzy concept. And then we go through the fractional calculus. It's a very hot topic nowadays, and how we can develop the fractional calculus based on fuzzy concept. And last one, we go through the numerical methods and decision-making algorithm based on fuzzy concept, because sometimes you can see that a lot of articles considered based on fuzzy differential equations, while the numerical method is completely non-fuzzy. So it means that they develop the fuzzy concept for the article completely wrong. And so at first, to raise your motivation for this issue, I want to share with you some articles, the recent works, and also some others from prominent researchers in this field, to see that if we do not have good knowledge of fuzzy, so then it leads to a wrong approach in our articles, and then maybe once we publish the articles, even if we can publish them, then the results are wrong. Maybe the journals currently, they have a good reviewers and they reject your articles. Maybe they blame you because of such results. That's why it's very important to be familiar with the not only fuzzy concept, but also how you can employ fuzzy concept for differential equations, for decision-making algorithm, for machine learning algorithm, and so on. Let's share my screen. Yeah, should be here. And okay. I move it to see that. Okay, here. Okay, this is the one of the articles recently published. At first, I just want to ask you to have a look on the problem of the poor knowledge of others, on developing the concept of fuzzy. So if you can see that the journal is a very high impact journal, so it's the impact factor is around 10. Very high impact factor journal in Elsevier. You can check it, chaos, solitons, and fractals. The article published in 2020, so very recently published, and the authors tried to develop the concept of fuzzy for fractional differential equations and with application to COVID-19 itself. You know that the pandemic situations is makes some hot topics in the literature, and a lot of investigator, researcher try to link their own research to the pandemic situation. So the others are from China, Pakistan, and Mexico, and so they develop a concept of fuzzy. Actually, they use some definitions that we, for example, I and my colleague propose in the literature, and then they use it or refer, at least they refer it to the definition. But once you go through the results that they develop, you can see that the results are completely wrong. And so why? Because sometimes I tell to my postgraduate students that the knowledge of fuzzy is not only you have knowledge about alpha cuts of the fuzzy numbers. We will discuss about alpha cuts, don't worry. So if you know that you are familiar with the alpha cuts, then you are proud that you have knowledge of fuzzy, and you start to write articles, and you can see that in the literature, even very high and top journals like this journal, so you publish wrong results. Again, what we have, another article published in 2021 by others from Jordan and so from Saudi Arabia. Again, same journal. So why I want to raise your attention to this problem, because you are undergraduate students, and then if you start to read the textbooks of fuzzy from now, then you have a very strong foundation that you can continue this, or you can bring this foundation to your postgraduate level, and then your results, your articles, your theses will be very strong. And so you have something to discuss with the fuzzy community, to discuss with the research community, and so on, with the strong and correct and novel ideas. So this is the second article that I wanted to share with you, to see that why, again, the others, maybe I discuss on the session that want to talk about fuzzy fractional calculus. In the third session, I bring these articles and discuss in details that which part has a problem. So this is the second one. And last one, this article published in 2014 by Soft Computing Journal, the journal which consider mainly fuzzy articles, and the editors of this journal so are expert in fuzzy and prominent in this area. And so recently also I joined to the editorial board of this journal, but I know that they are familiar, completely familiar with the fuzzy, and most important that this guy, Tawfiq Allabiranlu, is one of the frontiers also in fuzzy, but once you check the article, you can see that the article, the theorems are correct, but the others could not correctly develop the numerical method for fuzzy differential equation, and results here they proposed are completely wrong. So it's not good for a senior researcher in fuzzy to publish such articles with poor and wrong results. Why we have such cases? I can bring a lot of more. Why we have such cases? Because I, as a supervisor, you as a student, do not pay attention to the fact that fuzzy implementation of fuzzy is very important, as well as the knowledge of the theorem. If I have the knowledge of fuzzy, but I cannot develop properly the fuzzy concept into differential equation, into numerical method, then we have such wrong articles, maybe. So where in the near future, such articles will be withdrawn or retract from the journals, because some researchers write notes or write retraction notice to the editor-in-chief of the journal and ask to retract such articles due to the problem. This is what I wanted at first to share with you, to get your attention to the fact that if you are in the best time to start to read some textbooks of fuzzy. I can share maybe at the end of sessions, I share some useful fuzzy books for you to start to read them. And then if you want to continue on the postgraduate level to work on fuzzy, which is a very hot topic, and you can have a lot of ideas that you can cook them and publish in a good journals, and then so continue as a good researcher in this area. This is the exact time for you as a undergraduate student. So to sum up, I want all of you to pay attention to what we want to learn together. Even I, as a researcher that work on this topic from around 2009, 2010. So once I review these definitions, still I can find some new thing for me. Still I can remind some important point so for myself, and then help me to understand better this concept. And so, for example, I can show you in the next session, yes, maybe next 2 sessions, an article, important article that I have read it for more than 50 times. And every time I found new thing or interesting thing from different perspective. Okay. So let's start with our today session. Fuzzy logic, concepts and definitions. Today, what we want to learn, so this is an introduction, I try to collect some important things on fuzzy logic for you to have a list, at least a brief list of what you need to learn. Then it is with you to continue this way and learn more and more on the fuzzy concept. And I believe that if you can learn all of these parts, all of these definitions, concepts, then you will be definitely a good researcher with a lot of idea and even useful idea for economy of your country, because decision makers they critically need to consider fuzzy concept on their own decision. If they are economists, if they are biologists, if they are engineers, they need critically to have the fuzzy in their models. And I have worked with the biologists, economists, and so our computer scientists. We can see that the models based on fuzzy are much more effective than non-fuzzy ones, even than random ones, the stochastic one, because the stochastic random has a higher computational cost compared with the fuzzy. Okay, so what we want to learn, a very brief history of fuzzy. What was the nation of fuzzy, the origin of fuzzy? Because we need to know that why the researchers have been motivated to consider fuzzy. If there is not any gap, if there is not any problem, then human beings are not interested to explore new things. So we actually need to have a look on history to see that why the human being on that time needed to propose this new concept. It's not very long time that we have fuzzy. So for example, we have fractional calculus for around 100 years ago. But for fuzzy, fractional calculus was for 100 years ago. But interesting thing that in the very recent years, like 10 years, 15 years, the scientists found that they have a lot of applications based on fractional calculus. So we put it aside for now. But for fuzzy, we have for example, around from 70 decades, so started to work on fuzzy, and then if we want to talk about the applications from 2000 and up to now, the researchers found that they can propose a lot of models based on fuzzy. And so this is, you can see that it's a very young topic, still a lot of things that you can discover and explore as a researcher if you are interested. So at first, history. Then we go through a comparison between crisp and fuzzy. What is the crisp? Crisp is the meaning that we link this name to all the things which are not fuzzy. So if I want to classify the crisp and fuzzy, I can say that anything that is not fuzzy, we call it a non-fuzzy or crisp. So don't confuse your mind. Crisp is only non-fuzzy sets. Okay? And then we will have a look on operations. So if we have a fuzzy set, then is there any difference between the summation, subtraction, division that we have in fuzzy with non-fuzzy, or I tell that crisp. If there is, what are the operations? And then we will talk about membership functions. So fuzzy sets has a membership functions. We will talk about it, but we have a look on membership. Then extension principle, so proposed by the inventor of fuzzy, Zadeh. He's a Iranian American scientist, proposed fuzzy. So he proposed the extension principle is an important algorithm. We will talk about it. And then we reach to the fuzzy differential equation for the next session and numerical methods and so on. So for the fuzzy differential equations, we should have a look on the different fuzzy difference. So we have some fuzzy differences, means that, for example, if I can tell that if we have like what we can say, like y prime equal x minus 3. This is for non-fuzzy, a very simple ODE, and we have y at 0 is equal, for example, 1. Then once we want to talk about this one in the fuzzy, then we should care about the difference. We usually write the difference like this one, minus 3. So then we should check that this 3 is, I want to write it as a non-fuzzy number or a fuzzy number. We discuss about, and here the initial value condition. So if it's A, so we consider that here is equal B. It is a fuzzy number, and how we should define it. Then we have different fuzzy difference, means that sometimes we use this notation as a specific definition. Sometimes we have this notation, and sometimes we have this notation. We will talk about the fuzzy differences, the most common one, and so the application in the differential equation, fuzzy differential equations. And so generally, I hope that after this mini course or short course, I could make some motivations, at least for some of you, to start to read about this interesting topic and continue on the postgraduate level. And then so I also will be ready to help you in this level. Any question and any type of help, I will be available to support you, and it's definitely enjoyable for me. So what we have is that we will talk about the fuzzy differential equation and numerical methods. At first, we will go through the fuzzy sets. At first, we want to know that what is the meaning of fuzzy sets. This is the first thing that we should learn. But just a quotation from the Albert Einstein. I always repeat this quotation in my workshops related to the fuzzy, because showing the fact about the demand of employing fuzzy. So he told that as far as the laws of mathematics refer to reality, they are not certain. And as far as they are certain, they don't refer to reality. If I want to interpret it, it means that if we want to model the real world systems. If I, as a researcher, want to develop a model for any application, biology, chemistry, medicine, anything that you are interested in. So if you don't consider uncertainty, then the model is not perfectly linked to the real world system behavior. I can give you a lot of examples. So if I have time in the next session, I can bring for you the articles that show that if the authors propose the model and then compare the experimental results based on the non-fuzzy and the experimental results based on the fuzzy, then you can see that before proposing fuzzy, a lot of experimental results are deleted because the theoretical model, the mathematical model, prove or show that these results are not correct. Why? They are definitely correct, but the problem is that that model could not consider uncertain parameter to include some data from the experimental results, and so prove that the experimental results are enough correct. And the researchers usually delete some of their experimental results because the theoretical model show that these part of results are not adapted with the theoretical results, so you should delete it. But once we employ a fuzzy model, once we develop a fuzzy model, then we can see that no, a part of that results are correct. That's why this quotation is important. It's try to say that if we want to have a model close to the real behavior of any physical or real world system, then we should definitely consider uncertainty. Like the pandemic situation. We are still in the pandemic situation. We have a lot of positive COVID cases recently. And so we have from 2020 up to now, this problem. And so we had a research in collaboration with some hospitals in Italy, the National Hospital of Malaysia, and so on that research, we employ a dynamic model for the pandemic situations and insert some vaccination factors, the number of beds, and so on a lot. And we prove that if we employ uncertainty, the results are more realistic compared with the situation that we could not insert the uncertainty. But the problem is that how we should implement uncertainty to have a correct result, not like the article that I show you. So this is the important quotation. And the definition of fuzzy. Fuzzy logic, a method. So it's not a keyword. It's not a segment that or it's not a function that we tell that, so this function is a fuzzy. No, the fuzzy is a method of interpretation or day-to-day conversation to the mathematical concept that still we have the real conversation, but we can transfer somehow our feelings somehow or adjectives based on the fuzzy concept. While before that, if we wanted to interpret or feeling or adjective or description based on the mathematics, we had a solid framework, and so we could not explain our feelings based on mathematics. But in fuzzy, try to use some or employ some membership functions, not the Boolean logic like only 0 and 1, to express our feelings, to give us an interval of numbers that in this interval we can have more data, while before that we usually lose or some of these data because they are not in the definition of or solid mathematical formula. So fuzzy logic is a method try to addressing the vagueness, try to addressing the vague terms by using some membership functions and not like Boolean logic. But not only 0 and 1 like Boolean logic, but also all the numbers between 0 and 1. This is the meaning of fuzzy logic. But what are the examples of uncertainty? Because sometimes we want to address uncertainty. We can see a lot of articles or textbooks that mention that developing differential equation under uncertainty. But which type of uncertainty? We have different type of uncertainty that we can address using stochastic, random, fuzzy. So it's important to know, like stochastic uncertainty, rolling a dice. It's a type of uncertainty because we don't know what happened, and so we address it using a stochastic parameter. Linguistic uncertainty. The linguistic uncertainty, it is what we usually in our day-to-day conversation use it. We talk that, for example, about the price in the society. So for example, so the petrol today is rise up, the rice fall down, and so it has a low price, it has a high price, it's expensive, it's cheap. But if we want to I have a question that if I want to transfer or interpret this meaning cheap, expensive to the mathematics formula, I'm talking about the mathematical formula, how we can explain it? So before that, we could say that for cheap, like, sorry for my handwriting, so it's related to my pen, not my exact. So sorry. Like we have cheap or we have expensive. So just forget about fuzzy. I want to say that today's rice is cheap. Okay. So, but tomorrow rice is expensive. Today. So we are talking about tomorrow. Today is cheap about rice. And so tomorrow is expensive. How can I state it based on mathematics notation? Anything that you have in your mind. if I want to state it or write a quote that, for example, if it is $10 per kilogram, so or less than $10, then I tell that it's cheap, and greater than $10, I tell that it's expensive. Okay, so if we have here the price is less than $10 or greater than $10, less than we consider cheap and greater consider expensive. So means that $10 and 1 cent, it's expensive, and $15 is also expensive. So because for $10 I consider as the indicator, so for greater than $10 I assign a membership like 1, like for any amount greater than $10 I assign 1, any amount less than $10 I assign a membership like 0. For example, if it's $9, then I say that, oh, it's good, so 0. If it's greater than $10, I should say 1. For if I want to use Boolean logic, then it's 1 and expensive. But is there any difference between $9 and $5? The Boolean logic tell us no difference. Both are cheap. But we know that $9 is cheap, but $5 is very cheap. $10 is 10.1 is expensive. $15 is very expensive. But if I want to state it based on Boolean logic, I don't have any other option except assigning 0 to the cheap for any range and assigning 1 to the expensive for any amount greater than 10. This is the problem of our classical mathematics. Cannot interpret some concepts that we are facing or in our day-to-day life. So this is one of the motivation for the inventor of fuzzy logic to propose this concept. I will talk about it. So in the next slide. So the problem, I will bring for you some examples to make it clear that how we should stay. Just wanted to clear it in your mind that why we need to consider fuzzy. Why? Because sometimes we cannot state our feelings. I am 40 years old. Okay, so I am 40 years old. You are, for example, the statistics from United Nations say that, for example, up to 45 years, you are still in the classification of young people. Okay, I'm 40 years old. You are, for example, 20 years old, and my brother is 46. So I am young. You are also, based on the United Nations definition, I am young, still young, with 40 years old. You are with the 20 years old and young. But we know that there is a huge difference between me with the 40 years old and you with the 20 years old. We are still young. Yeah, I'm still young and feel that like 27 years old, really. So I'm still think that I'm a fresh Ph.D. graduated, and sometimes I do something that are so for example, my wife tell me that, oh, it's not good for your age, you are now 40 years old, but I am still spiritually, I still feel that I'm like a 27, 28, but I should consider the real things. So I'm 40 years, you are 20, some others 32, but based on United Nations definition, all of us in the young definition, the definition for young guys. And then a guy with a 46 years old is an old man. Only 1 year difference from 45 up to 46. This is the problem. So linguistic is important. Informational uncertainty we have. So like the honesty, creditworthiness. So honesty, I tell you about the honesty is another adjective. So I'm an honest guy. For example, just my mom called me that, when did you get up today morning? And I tell that I got up, for example, around 9 o'clock, but I tell to her that, oh, I'm an early morning man, I got up 6 o'clock. So I lie. I was not honest, but it's different with difference between me and some other that have some fraud. Some other that have so killing some others, and then the police, once they ask them that, so you killed that guy, they say that no, I swear, my God, so I did not do. Is there any difference between the honesty, the rate of honesty of that guy and me? Definitely we have a difference. But the current classical mathematics say that you are sane. If you are not honest, then no matter what is the rate. We cannot classify it in the current mathematics. We cannot make a difference. That's why informational uncertainty, linguistic uncertainty are important. So this is an example to make it more clear for you, because this definition should properly embed in your mind. That if temperature is cold and oil is cheap, then heating is high. This is an example. We have some linguistic concepts: temperature, cold, the adjective here, cold, cheap, high. How much the temperature is cold? I now currently, for example, you are in Jakarta, so the temperature is cold while you have a weather like I don't know, for example, 15 degree of centigrade. So then you say that, the weather is cold. But if I was in Australia, in Canada, so and tell me 15 degree of centigrade, so it's cold, they laugh. Believe me, because for them, 15 degree of centigrade is a very nice weather, and they use short sleeve, they go to some proper beach. For them is minus 20 degree of centigrade is cold. For example, I was for a couple of days ago, yeah, I think. So I called my friend in Canada, in Toronto. So I told him that, here in Melbourne, we have a very cold weather. So told me that, how much now currently in Melbourne? I told him that I think that it was 17 degree of centigrade. Then tell me, Ali, Leave it. So it's ridiculous. In the 70 degrees of centigrade, we go to the beach. We wear a short sleeve shirt, and then you tell me, oh, I wear coats, I wear hats. The difference. So how we can tell, how we can state this difference between the meaning of adjective, meaning of, for example, in Canada, different meaning here, in Australia, there in Indonesia. The temperature is cold, oil is cheap, heating is high. We have linguistic variable here and linguistic value. The linguistic variables of temperature, oil, and heating. And linguistic values that we use for these variables are cold, cheap, and high. The interesting thing is that if I want to have more correct data in my set of data that I have, so I need to consider some functions. Here is a mu, so it's a membership, for membership, stand for membership function. Mu for cold, the mu a function for cheap, and a function for high. Function for linguistic values. Then these functions can take some values to help us to interpret this adjective and explain it based on mathematics notation. So we define here the membership for each linguistic value. These linguistic values are related to the linguistic variables. So, and then we can have a linguistic variable definition, which is characterized by some terms that you can see, like the linguistic variable, the membership function. Here we define it, the linguistic variable, I stated based on X. The membership function, I stated by T or mu, don't worry. So the universe, the whole of set that we have, and some synthetic rule or semantic rule, no matter. So we don't need to consider now. We just important for us if are these two terms. The first is the linguistic variable, and second one, the relevant linguistic membership. We here put it mu, or we can consider the T or anything. This definition proposed initially by Zade in 1973. You can see that it's around 50 years old. Not very old age, not past history, long time, only around 50 years. 50 years in science is not too long. But you can see that in the recent years, we have a lot of application of this one. This guy, Zadeh, I think that 2-3 years ago passed away. But see, the scientists discovered new things, new definitions for fuzzy, new definitions for differential equation based on fuzzy, new definitions based on formation length, and so on. So the first thing is that if you want to explain the linguistic variable that we have here, and it has a relevant adjective or linguistic value, so we need to define a function. This is what Zadeh in 1973 proposed, because at first he wanted to, he collect all these results in a PhD thesis and then try to defend on this concept the examination committee at first were against this concept. They wanted to reject his thesis, PhD thesis, but after making a very strong and comprehensive and Viva, yeah, they accept that this is the new and considerable concept that they can pay attention. They can take it as a new branch of science in mathematics and develop it in other branch as well. While he proposing controls for control system, so the basic was mathematics, as you can see. And so I want to pass some of these slides quickly, but I can see that we need to know about everything perfectly, and I try to get it to you or learn it together, because it's, as I mentioned, remind for me as well. So that's why sometimes I stop on slide to discuss more. So if we want to have if we want to make some boundaries, because sometimes I can see that my student asks me that, is there any difference between fuzzy and probability? Because in fuzzy also we have a membership, in probability we have membership. Then why we need to have fuzzy? If we want to consider probability, if we want to consider some boundary, it's not very exactly the situation, just we want to assume or imagine that we have some boundary. So this is the deterministic part. Deterministic means that the crisp one, the non-fuzzy one. So I just provide some different words, because maybe in the textbook article you will be faced with the different words like deterministic, non-deterministic, crisp, non-crisp, and so on. So deterministic means that our parameters are certain. We don't have any uncertainty, we don't have any fuzzy, random, stochastic, and so on. Okay, so this is the part of fuzzy deterministic. Here, if we assume that you have a universe, this is the universe, the whole data that we have. This part is stochastic. All the data that we have based on a stochastic concept. And this part is the fuzzy uncertainty, vagueness. And then this part is non-deterministic. Okay, so what it means that if we collect all data that we have in the universe, and a part of this data are deterministic, a part of this data is based on stochastic concept, a part based on random. So like this part we can consider as a random. A part is fuzzy, and some non-deterministic means that they are not fuzzy, they are not stochastic, they are not random, something else. Still, the scientists have not discovered that what are we have beside the stochastic, fuzzy, deterministic, and random, and so on. Probability, we have something more. What we can say that some indicators from the nature, some reflection from the nature, if I mention better, yes, some reflection from the nature demonstrate that we have something more. Fuzzy, we have some models should be developed based on uncertainty, because nature told us that it is not deterministic. So the researcher invented the fuzzy. The researcher proposed the stochastic, random. But still, if we hear from the nature, if we pay attention to the nature, we can see that still we have some other concepts. Maybe in the next years, next decade, some other tell new thing that for new other models. Discovering the space, we can find a new concept. We still do not know about this part. So, but this part is fuzzy. This is what we want to have it. Fuzzy is a parameter, maybe linguistic parameter, with the function that try to address vagueness, try to interpret your feeling, your conversation to the mathematics. So this is a short story. Proposed first article in the seminar. So by Zadeh, Lotfi Zadeh was a frontier in Berkeley. He proposed the fuzzy logic, and then his supervisor supported to continue. And sometimes this is important thing for us as a supervisor. So I just open a parenthesis that sometimes the students want to explore. Maybe I have seen sometimes my student come to me with a new thing he wants or she wants to explore and maybe move or pass me, and then we need to support them. We need to accompany with them to that maybe after beyond this problem he can or she can propose new concept. We as a supervisor needs to support, not I tell usually to my Ph.D. students say that, so I am learning something with you because I can conduct you, but I don't have the knowledge that you are exploring. I can give you some points, but you are the person that working on your thesis. Sometimes they give me some new knowledge, even I have not pay attention, and so interesting for me. That's why I tell that if the supervisor of Zadeh on that time did not support and told to him that no, you should stop, only work on deterministic part, and it's not a good thing, so then we did not have fuzzy. So yeah, we as a supervisor needs to support. And then the first definition proposed in 1970 in the control engineering fuzzy logic, then 75 the introduction of fuzzy logic in Japan. You can see that around 40 years old. And then we had an application in Europe, then US. And so interesting thing is that only we have for 20 years, the application, the real application of fuzzy in the engineering problem. Then, what is the difference between crisp and fuzzy logic? Which one I select? Sometimes we still have some researchers that are against fuzzy. Today, so if we propose to them that you need to consider fuzzy, they tell that it's not a science, it's not knowledge, it's just developing something that you invented to, which are from their point of view is useless. But the problem is that you can, if you are fair, you can see that there is a huge difference between the stochastic, random, fuzzy, and crisp. So crisp, as I told you before, crisp is non-fuzzy logic. Let's see the proposition. A proposition can be true or false. If there is any other option, please tell me. In mathematics, a proposition can be true or false. We don't have any other option. I'm talking about classical mathematics. Bob is a student. True. Smoking is healthy. False. Then I want to assign a function to this concept. So the degree of truth is 0 or 1 because we only have Boolean logic. We don't have any other logic system to address it. Bob is a student. True. Smoking is healthy. False. Then fuzzy logic is interesting here. So tell that William is young. Ariel, smart. Young, smart. Some adjectives that in our mind, we are trying to measure it. I tell that William is young. So then you ask me this question, how old is he? Then I tell you, for example, he is 32. Then you tell me, yeah, it's still young. Ariel is smart. Then you ask me how you could find that he's smart. I tell you that the IQ test so demonstrated that it's smart. Then how much was the output for the IQ test? What was the mark that he could achieve? So this is the adjectives that fuzzy logic here try to say that if William is young, yes, he's young, 35 years old, and then why? Because he's a 35, this is still young, I try to assign to him a membership value like mu, with the value mu for William is a 0.3. But for example, Ali is young, being 20 years old, he's 20-year-old, and then I assign to him a membership with 0.9. And so maybe, I don't know, John is a 15 years old, and then I assign to him a membership with 0.99. You can see that fuzzy is trying to collect all the data in a set, but with the different membership completely different from what we have in Boolean or classical mathematics. Then I want to stay this part, so crisp logic or crisp set based on the mathematical notation. The classical sets for, I just remind you, crisp means that non-fuzzy, okay? Like any set that we have. Say that an element belongs to a set or not. For example, A belongs to a capital A or not. We don't have any other option. Belong or not. We show it, X belongs to A or X doesn't belong to A. We do not have any other option. Then, if I want to define a membership for crisp set, if it belongs to A, so I write a membership 1. If it doesn't belong to A, I write a membership 0, the value that I assign. So, and then you can see that the domain of our function is only 0 and 1. Very, very, very easy. So we do not have anything else. Classical set, blind or not blind, membership, if I want to define, if it belongs, I consider 1, if it doesn't belong, 0. Then, an example. We want to show that we have this one. So we have a universe. The universe here is that set of old people. And then the young people means that age less than or equal 25 years old, we say that they are young. So for example, I am 23, I'm young. So means that I write it, a membership is 1. You are 18, so young. I want to write the collection, so and say, and for example, another guy is a 26, he is not young. Another guy 40, he is not young, and so on. Because we have an option, if it's young, he's young or she is young, less than 25, I consider 1. Greater than 25, what should I do? I consider 0. And then I want to plot this data. You can see that for all data less than 25, the value is 1, for rest 0. This is the figure coming from our data that we have. For all young people less than or equal 25. Then fuzzy. Fuzzy set. The fuzzy sets say that you have the membership values, you have the membership mu a not only 0 and 1, but also, you remember the definition of fuzzy, but also all the values between 0 and 1. Then if we plot, or if we consider again this collection, we do not have such plot. We have you can see that we have a drop, but not sharp as you can see like Chris. We have some more data here that we can assign them. We can consider them as the young people, but for example, with the lower values or smaller values of membership. Like for example, membership for the X 0.2 or 0.1. For what are the X? X is a guy with the 26. X is a guy with the 30. They are still young, and fuzzy allow us to consider in this collection. And you can see that once we compare, fuzzy is trying to transfer the meaning of use in a better way than classical mathematics give us. Otherwise, you can see that what we have here only 0 and 1, and anybody 26. So if anybody come with the 26, we deny that. So, oh, you are not young. And tell him you are not young, so leads to make a suicide, because 26 is still young. But based on the classical mathematics, he's not young. So this is the article. This is this guy, the founder of fuzzy logic, Zadeh, Lotfi Zadeh. And this is the article he published in 1965. If you search this article, I ask you to Google it in Google Scholar. So, and you can see that how many citations this article received up to now. This guy passed away, but the trace of his interesting concept shared with the world, still you can see and refer to this article. Still to nowadays, A lot of articles cite this one, even so maybe not relevant to their own works, but to make appreciation to this guy, they cited this article because in this article, for the first time proposed the concept that I explained here, the concept of fuzzy set in 1965, in only 15 pages. And if you read the textbook about fuzzy, and then you look at this article, you can see that the article is not very complicated compared with what we have here about fuzzy, the information. But on that time was a new thing on fuzzy, because he was the guy who proposed this new logic. So again, we have another to remind for ourselves what is the meaning of fuzzy. The traditional representation of the classical mathematics or Boolean logic say that we have two clusters of these animals. They are fast, they are slow. The fast one is like cheetah or tiger. I can see that this is cheetah, maybe, so you can see like tiger. Anyway, so this is cheetah. So because it's one of the fastest animal in the world, so we give him a Boolean logic value equal 1. And for a snake, it is one of the slowest one, we consider speed equals 0. Then I want to write a algorithm, then to write a code. So algorithm says that if you have a speed equals 0, then system should return speed is slow. If you return so anything else, anything except 0, then it's fast. This is the traditional representation. So make a sense from you in your mind or not, this is what we discuss about it, what we accepted. Even nowadays, some of the researchers still accept this theory, say that this is the correct one and they don't accept fuzzy. But before fuzzy, this is the representation of the logic that we have, the Boolean logic. But the problem is that what we can do about turtle, what we can do about dog is fast, but there is a difference between cheetah and tiger and dog. There is a difference between snail and turtle. The fuzzy tell that yes, there is a difference. I want to write a new algorithm for you. In this algorithm, if the membership function is between greater than 0 and less than 0.25, then the speed is slowest. If it's greater than or equals 0.25 and less than 0.5, then speed is slow. Greater or equal 0.5 and less than 0.75, then speed is fast, and last one is less than or equal 1, so and greater or equal 0.75, speed is fast. This is the difference between fuzzy and crisp or non-fuzzy. Trying to collect all of them. Like I sometimes I give this example, maybe so to my student, maybe for you is so not very good, but I try to fuzzy is like a nice grandpa, so that has some grandchildren. So these grandchildren from one of them from his his daughter, but one of them from his stepdaughter. And so for us, his original grandson or granddaughter, so is only the kid that's coming from his own daughter. But because he's a very nice grandpa, he say that no, this step daughter is also my grandson or granddaughter. Please don't refuse it. Why? Another grandpa say that no, it's not mine. I only consider the grandson or granddaughter coming from my own daughter or my own son. This is the difference between fuzzy and non-fuzzy. Fuzzy tell that some data that before that we threw out, so say that no, they are useful. We can have them in the collection. With this concept, turtle is not slowest one. Turtle is slow. We cannot ignore him or make him in the same level with the snake. And also cheetah is the fastest one. Why we should consider in the same level with dog? Their speed is completely different. And Fuzzy say that yes, you are right. And we need to have new knowledge to interpret this adjective, linguistic adjective. Another example, in the classical Boolean theory, so we say that we have a strong fever if your fever is in the range, so greater than 39. But if you have 38, 38.7, so don't have fever. But in Fuzzy say that we do not have any exact boundary. The boundary you can see here, the boundary is vague. You cannot detect the boundary exactly because in this set, 38 also belongs to this part with a very small membership like 0.01. While here is equal 0. This is the difference that, for example, if even in medicine, if we consider the fuzzy model, we can sometimes survive some bodies because it's very simple. We write some codes for our software, and software analyze based on our codes only. The system cannot interpret and so different from what we insert, the data, the so the input. But if our model based on fuzzy, then system return that this one also needs to pay attention. The problem is that the next step is that we have fuzzy set, and the fuzzy set has a membership. Then how we should state it based on the mathematics notation, I mean. So this is the definition. If we have a collection of the object, anything, the universe, and then we want to have a fuzzy set defined in the universe, then we write this set like this one, X, the parameter, the linguistic parameter, anything, and the linguistic membership mu A, X. For all X belong to you. This membership function, the domain is universe and the range a closed set between 0 and 1. This is the membership function. And if I want to donate, so to indicate a fuzzy set, I have I should follow this one. We have other notation I will explain, but the most common one is the fuzzy set showing the pairs with the X and the relevant membership. Like you can see that this is an example. This is for discrete fuzzy set, okay? We are still in discrete, don't talk about continuous one. If we have a universe 1, 2, 3, up to 8 courses student may take in a semester, then so it has some membership. For 1, we consider 0.1. For 2, 0.3, up to 8, we consider 0.1. And if we want to plot it, so for each course, we plot the relevant value for membership. You can see that you usually here consider the normalized membership function. The normalized membership function is a membership function with the range between 0 and 1, the closed form. And so we have this one, as I mentioned here, we have this one as the most common notation for expressing the fuzzy set. But sometimes in the textbook, like one of the oldest textbook in the fuzzy is written by Zimmerman, if you check, he also proposed another representation. So this one is the membership, and this one is the member of the set. Also this summation is not actually summation. It's just for connecting, putting all the members in this demonstration. So we have now the continuous one. So we already had the discrete fuzzy set. So in discrete, you can see that we explain or a pair. The first one is the element, and the second one, the membership, specific or unique membership for this one. Now we have the continuous one. The continuous one, for example, this is the membership function. It's a continuous. Why we call it continuous? Because our data talking about all the people with about 50 years old. Then we assign this membership. All the people with 50 years old, for example, I'm 51 years old, then the value is like the mu b 51 is equal 1 over 1 plus 51 minus 50 over 4 to the power of 4. Then you should get it something. So I am 52, 53. So if we collect all, then we have this one, the membership, and we can plot it. This plot is a result of these values, all the people with the greater than 50. So what we have here, even if we have, for example, if it is a 50 years old, then we have 1. So you can see that for 50 years old, if we write it is 0 here, should be 0 and 1 over 1. So this is the for 50 years old, the biggest value. And then you can see that we can consider, for example, 40 years old. 40 years old, if we put it 40 years old, we still have membership value for it. Means that we are talking about 50 years old. 40 years old is also about 50 years old. 45 is about, and they have specific membership value. While for the classical ones, we cannot include such age in the Boolean logic system. So this is the continuous one, the continuous fuzzy set with the specific membership function. It is normalized. We'll talk about normalized definition later. So it's a normalized membership, and you can see the value. So an alternative representation, this is for discrete one, another representation. We have also for continuous one, except this one that is very common. So we can use also this one as another representation in some textbooks. It's not integration notation, it's just for notation for standing for fuzzy continuous set, continuous fuzzy set. So you can see that we have alternative notation. For discrete, we can use the summation, and for continuous, we can use the discretion. As mentioned, that this summation and integration only is for showing the fuzzy, not the meaning of summation or integration that we have in our mind. So I reach to the membership function. I prefer to stop here and now open for any question and answer if there is anything. So it's with you, with the chairman of the panel, to if there is any question or problem, please ask.
Okay, thank you. Okay, for all the participants, if you have any question, you can unmute yourself and ask directly to Dr. Ali, please. Anyone? Okay, okay, doctor, there is one question from Mr. Muhammadun. Okay, I will read it for you. I apologize for asking of the topic. I see that your age index on Google Scholar is very high, namely 34 at your young age. What is the secret and how can you achieve it? Thanks.
Thank you, Mr. Muhammadun. So I believe that I'm still young. So sometimes, yeah, I feel that, as I mentioned, I'm like 27, but actually I'm 40 years. So I recently, yeah, I have been listed as a 2% top scientist in the world. So the secret is that you should work hard, and you should have a strong passion about your research. I mean that if you don't have strong passion, you cannot success, not only in our fields, but also in any other field. So sometimes I study, I work more than 14 hours per day. And sometimes even in weekend, I work, although my family complain. And so, but fortunately, because my wife also is a researcher in nanotechnology, so she can understand me better. So, but yes, you should work hard. Maybe in future, I give you if you have time, I give you a workshop on how we should write some secrets of how you should write a good article. I have seen, honestly, I have seen a lot of workshops on how you publish high impact factor articles, how you publish a good article. But maybe in future, I open some secrets, real secrets, how you should write a real good article to publish in high impact factor journal. Because, for example, I am currently an editor of more than 40 journals in the world. And I want to show you the beyond of journals. And it is important. If you know the policy of writing for journal, then you will be successful on getting published good works. And yes, thanks for you to assign the use rate for me. But I'm 40 years old, I'm still young. And yeah, the best thing that I should say, I have a strong passion about my research. I love it. And this is what I am standing this point. Thanks. So what's outcome of the implementation of fuzzy? Is the membership group only? No, thank you for your question. No, the outcome of implementation of fuzzy is not membership. The membership is the first step of knowing about fuzzy set. In the next sessions, we will continue and then we will go through the differential equation. In differential equations, you can see that we cannot deal with the differential equations by employing the membership. We should what we can say that we should cut some part of this membership and work with another part of membership, which is called alpha cut. And in differential equation, in the dynamic system, the scientists working with the alpha cut, which is a part of membership. Then they develop the fuzzy, like in differential equation, like in decision algorithm, like in machine learning. We are actually with the alpha cut, which is a part of fuzzy set, but we will explain it. In this step, we just wanted to embed in more mind about fuzzy set, membership, and so
on. Okay, thank you. Is there any question? I guess that's a good collaboration for the next year, I guess, if you can share your secret, how to write a good article. And how about a collaboration? Do you often open on collaboration with other researchers?
Yes, definitely. I'm always looking for the new young researcher to collaborate with me. And now currently I have collaboration with the US, China, Turkey, and so Malaysia still. And why not? I definitely like the language, the environment, the weather that you have, and like Indonesia, Malaysia. So I'm very interested in collaborating with the young researcher, because young researchers comes with new idea that motivate me to feel that I'm still young and can do more things. So anybody is interested to work on fuzzy, to work on the maybe fuzzy fractional, available to support and collaborate.
Okay. Okay. Any more questions from the participants?
Yeah. Thank you for asking. Ms. Anis asked that I want to ask about what are the advantages of fuzzy logic comparable to using other logic to solve a problem. So I provided here some examples of what are the difference between fuzzy and non-fuzzy. So what type of data we will miss if we don't use fuzzy. So I can maybe in the last session, I bring for you some articles to show you the real world system that we employ the non-fuzzy and then fuzzy. Then you can see that if we don't employ fuzzy, we have a problem, or we miss some important data in the empirical science, like chemistry, like drug delivery. I was engaged with a project on drug delivery system. On that project, we validate that if we use a dynamic system based on differential equation, what are the results, and fuzzy differential equation, what are the results, then we compare that out. They're hugely different. I will definitely provide in the last session, after we have a review on the fuzzy, I give you some articles to see that what are the advantages of fuzzy logic, why we need to hire it, and so we can use differential equation, why we need to fuzzify it. And I will bring articles. I hope that I can keeping my mind. I'm still young, but sometimes I'm busy mind forgot. But I try to bring for you some articles to show you, to demonstrate the effectiveness of this concept. Thanks for your question.
Thank you, Anis. Okay, is there any question? Any more question? Okay, no? Okay, looks like we answered all the questions. Okay, Doctor, is there anything else you would like to mention before we end this course?
Oh, thank you so much for your attention.
Okay, oh, there is one more question.
Oh, so which Malaysia hospital? I don't work for Malaysia hospital. I did a research collaboration with the national HUKM, National Hospital of Malaysia. So I collaborate with the Professor Yazid Bajuri on working on COVID-19 and develop, and we got the results, collect the data from that hospital to develop a model for pandemic situation. I saw the abbreviation of the hospital is HUKM or the Hospital of University Kebangsaan Malaysia, or the Hospital of National University of Malaysia. Welcome.
Okay, I guess Tulasi is not from University of Erlangga, right? I guess is from international student here. Okay,
INTI. Yeah, we have an INTI university branch, one branch also we have in Malaysia. I think that, so we have same branch in Indonesia. Nice to hear. So good luck, Tulasi, with your I think that you are juniors, undergraduate student. Yeah, wish you best of luck. Thanks for your question. According to you, as the researcher about fuzzy, what are the strengths and weakness of fuzzy logic? Is there any problem that is not suitable for using fuzzy logic approach? Oh, thank you, San, for asking this question. Yeah, every branch of science, every concept has some strengths and weaknesses. And also for fuzzy, we have some weaknesses of for the big data. If you want to fuzzify them, I'm talking about a huge data or big data we call. So if we want to fuzzify, compare with the CRIS, maybe the computational cost is different, considerable different. So that's why it is a weakness of the fuzzy logic. But if we are looking for accuracy, sometimes in the model we are looking for accuracy, sometimes we are looking for the low computational cost. If we are looking for accuracy, the fuzzy logic is one of the best options. But sometimes in engineering problem or some even medical problem, so we need the have a lower computational cost. On that part, then we should evaluate that we should select fuzzy or deterministic or non-fuzzy, or go to the stochastic or random one. Yes, this is this weakness of the fuzzy, that sometimes we have some high computational cost, but has a lot of strengths I mentioned, and we will see that the strengths of the fuzzy, that so one of the most important strengths is that the models that we develop based on fuzzy is much closer to the real behavior of the system that we have. This is one of the most strength point of fuzzy.
Okay, thank you, Iksan.
Thanks. Thank you, Iksan.
Okay, any more questions? Okay, no more question, I guess. Okay, before we end this course, is there anything else you would like to mention, probably, Dr. Ali?
Oh, thank you so much again for your invitation. And so maybe at the last session or next session, I share with you some useful textbook, fuzzy textbook that help you to understand much more about fuzzy concept, because some parts we have to ignore, but maybe for you is interesting to consider. You can find in these textbooks. Still, I ask you, if you are interested in, start to read the textbook, and any problem or you are eager to collaboration, I'm really available for it. Thank you so much.
Okay, thank you. Okay, so I guess we are in the end of today's courses. So now I need to make some important announcements. The first one is a recorded version of this course will be available in Mathematics official YouTube channel. And the second one, I would like to remind you all the participants that next week on the same time, we will have another topic on fuzzy differential equation. So don't forget to join back next week. Okay, then thank you, Dr. Ali Ahmadian, for the great time on today's course. See you next week with different topic. Okay. And I guess we will invite our postgraduate student also for the next course, since this topic can be developed as their research.
Yeah.
Yeah. Okay.
Nice.
Thank you. And for all the participants, thank you for participating in today's courses. On the behalf of the committee, I would like to say sorry for any technical problems. See you all next week. Goodbye and thank you.
Thank you so much. Have a nice weekend.
Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you, Doctor.
Thanks.